So today we're going to be dealing with 10.2. So the first thing we're going to do is we're going to tear out that other piece of paper that we're going to be able to use for our homeworks. And we're going to tape in to our spiral notebook 10.2, this worksheet. So I'm just doing that for mine right now. I'll let you do that for yours as well. And this is dealing with graphing exponential functions. So today we're going to be dealing with graphing exponential functions. Now, you're going to need a calculator. It doesn't have to be a graphing calculator, but you need a calculator, a scientific calculator that you're going to be using with this. I have my graphing calculator with me at home. So we're going to start off with describing what is an exponential function. So an exponential function is a function in the form of y equals a times b to the x, where a is the beginning value or the initial value, and b is the growth or decay rate. And then an asymptote is a line a graph gets closer and closer to. That's kind of the simplistic way of saying what an asymptote is. You're going to get close and closer and closer to that, but you're never going to quite touch. So exponential growth, if you look at this first graph, it's going uphill. So that's exponential growth. Now, if we're looking at this, it's getting closer and closer and closer to the x-axis. Right there, that is our asymptote, and that is the equation y equals 0. So it's getting closer and closer and closer to that, but it's never quite getting that. Now, when we're dealing with end behavior, so we're going to assume this graph goes on forever in both directions. So as x approaches infinity, what happens to my y? Well, as x is getting bigger and bigger and bigger, my y is getting bigger and bigger and bigger. So y is approaching infinity. As x approaches negative infinity, so as x is getting smaller and smaller and smaller, what is my y approaching? It's getting closer and closer to 0. It's not quite hitting it, but it's getting closer and closer to 0. Now, in order for you to have an exponential function, an exponential growth, if you look down here, b, that's the big part, has to be greater than 1. B has to be greater than 1. If b is greater than 1 on an exponential function, it's going to increase. It's going to have exponential growth. Then when we go to decay, if we look down here, exponential decay, b is between 0 and 1. In other words, it's going to be a fraction between 0 and 1. So if we're looking at this graph, same thing. It's getting closer and closer to this line, never quite touching it. That is our asymptote. And then the graph is going forever that way and forever that way. So if we do our end behavior just like we did before, as x approaches infinity, so as x is getting closer and closer, bigger, 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 what's our y value getting closer and closer to? Y is getting closer and closer to 0. And then as x is getting bigger and bigger and bigger negatively, so it's going smaller this way, where's our y going? It's going up. So y is approaching positive infinity. So that's the basics of an exponential growth and an exponential decay function. So I'm going to go ahead and highlight that's exponential growth. That's our exponential decay. So now we're going to go start down in some problems. So we're going to start down where all we're going to be doing is looking at different examples stating what our a value, what our b value is, and then y-intercept and whether it's growth or decay. Now, before we get to that, we have to come and look up here. So if we're talking about y-intercept, that's where we hit this y-axis. So if that value is a, that y-intercept is 0, a. Here, right here, that value is also 0, a. That's our y-intercept when we're dealing with these. So our a value is going to be your y-intercept. So if we get here, our a value is 3, b value is 5, which makes our y-intercept 0, 3. Now, since our b, if we look at it, is greater than 0, is it growth or decay? It's going to be growth. Then we go to the next one. Our a value is -7. B value is 1/4. Y-intercept is going to be 0, and then our A value. And then if we look at this right here, this is less than 1, but greater than 0, which means it's going to be decay. Then we go to our next one. Our A value is -9. Our B value is 0.7. Y-intercept is 0, and then our A value, which is -9. And then we look at our B, and it's less than 1 and greater than 0, so it's going to be decay. And that's just the basics of how you tell what things are going to be, growth or decay. So now we're going to get down to actually graphing an exponential function. So to graph an exponential function, the very first thing we're going to do is we're going to make a table with x values from -2 to 2. So I'm going to go over to my table and I'm going to put my x values, -2, -1, 0, 1, 2. So that's the first thing. Next thing is, once we have our x values, all we have to do is we have to plug in our x values to find our y values. So if we do that, I'm going to just start with one at a time. So f of -2 means 3 times 2 to the -2. Anything to the negative power, remember that means you flip it and it goes on the bottom. So 2 to the second is 4, so this is 3/4. Then we go to our next one. F of -1. 3 times 2 to the -1. Negative exponent, so it flips it and goes on the bottom. And you get 3/2, or 1.5. Then we do 0, so f of 0. 3 times 2 to the 0. Anything to the 0 power is 1. So 3 times 1, which is 3, which we already knew. Our y-intercept was going to be 0, 3, based on our A value. Then we plug in a 1, and we get 3 times 2 to the 1. 3 times 2, which is 6. Then we plug in a 2, we get 3 times 2 to the second, which is 3 times 4, or 12. So once we plugged all those in and we have all our points, we're going to graph the points and our asymptote. So if I go to my graph, I'm going to go -2, +3/4. It doesn't quite hit 1. -1, 1.5, 0, 3, 1, 6, 2, 12. So if this is 10, 11, 12, about right there. And then I'm going to graph it. So there's my graph, and then I also have to graph my my asymptote, which is y equals 0. And I'm going to label my y-intercept, and that's at 0, 3. And that's how you would graph an exponential function. Now, before we move on, let's see. Based on what we know our A value is 3 and our B is 2. That's greater than 0, which means what should our graph do? It should be a growth function. It should grow exponentially, and it does. It grows really fast. So we always want to look at, is it a growth or is it a decay? That is a growth. So now flipping it over to the back, we're going to use what we know so far to be able to do all this. So in this case, A is 2, B is 1/4, which means that's less than 0. I'm sorry, less than 1, not less than 0. Less than 1 and greater than 0. Less than 1, greater than 0. Which means, is it a growth or decay? It is a decay. What's our y-intercept? We don't have to plug anything in to say that. Our y-intercept is 0, 2. What's our equation of our asymptote? For everything we're doing today, it's always going to be y equals 0. So now I'm going to plug in all my x values. So -2, -1, 0, 1, 2. Are you allowed to use a calculator to be able to find all those answers? Yes, you are. So I'm going to go 2 parentheses 1/4, close my parentheses, to the, that's this little caret here, -2 power. If I do that, I'm going to get 32. Then I'm going to do 2 parentheses 1/4 power to the -1, and I should get 8, 2 parentheses 1/4 to the 0 power. I should get 2, which we knew, because if you look at your y-intercept, that should be the same. Then we plug in a 1, so let's do that. 2 parentheses 1 divided by 4 to the first power. We get 0.5 or 1/2. 2 parentheses 1 divided by 4 to the 2 power. I get 0.125, or if I change it to fraction, 1/8. Now I'm going to go over here and I'm going to graph all of those. So -2, 32 is way, way up here. So we're going to just assume it's way up here somewhere. Then we have -1, 8, 0, 2, 1, 1/2, 2, 1/8. So my graph's going to look something like that. And we already said it was a decay, so now we're going to say decay. We're going to put our y equals 0, which is our asymptote, on there. We're going to label our y-intercept. And now we're going to answer all these questions. So, as x approaches infinity, what is happening to my y value? So as x is getting bigger and bigger, my y value is getting closer and closer to 0. Same thing with the next one. As x approaches negative infinity, so x is getting bigger and bigger negatively, where's my y going? It's going up. So it's approaching infinity. Then we look at our domain. Can x go forever to the right and forever to the left? Yes, it can, which means it's negative infinity to infinity. Our y value, does it ever hit 0? No, it doesn't. So that's why it's parentheses, and it's 0 to infinity, because it's starting here, going up forever that direction. So let's move on to the next problem. So a is -2, b is 1/2, which is less than 1, greater than 0, which means it is decay as well. What's our y-intercept? 0, -2. Equation of asymptote still is y equals 0. And we go ahead and plug in our coordinates, -2, -1, 0, 1, and 2. And at the same time, we can go over here and write decay. Now I'm going to plug those coordinates in. So go -2, parentheses, 1/2 to the -2 power, and I get -8. Then I plug in -2, parentheses, 1/2 to the -1 power, and I get -4. We already know that 0 is going to give me a -2. So we do -2, 1 parentheses, 1/2 to the first power. We get -1, -2 parentheses, 1/2 to the 2 power, and I get -0.5 or -1/2. Now I'm going to come over here and I'm going to graph it. So -2, -8, -1, -4, 0, -2, 1, -1, 2, -1/2. So our graph is going to look like that. So our asymptote is right here. So I'm drawing it on there, and I'm also going to label my y-intercept, 0, -2. So on this one, for end behavior, as x approaches infinity, x is getting bigger this way. What's y getting closer and closer to? 0. As x approaches -infinity, what's y approaching? So x is getting bigger this way, y is going down, which means it's getting closer and closer to -infinity. And then our domain, can we have all x's? Definitely, so -infinity to infinity. And our range is it starting down, which means -infinity. Where does it end? 0. And it doesn't ever hit 0, so it's a parentheses. Now, what is this used for? This is actually used for when they're dealing with money, when you're dealing for cost of all sorts of different things. So we're going to start off with this first problem. So a classic car was sold for $1,000 and its value increases by 5% each year after it is sold. If the function, so notice, there is our A value, and it increases by 5%, which means it's 1.05, because if all we did was put 0.05, we're not keeping the original. So this means it's 1 plus 5%, which means 1.05. That's what it means. So if the function gives the value of the car after X years, how much will it be worth in 4 years? So basically all we're going to do, first of all, is this a growth or decay? It's increasing, right? Which means it's going to be a growth. So in terms of work, they want to know how much is it going to be after 4 years. So we're going to take our function and we're going to plug in a 4 where we see the X. Now, when we plug this in our calculator, this is the important thing, you want to make sure that you put your answer in terms of money. So if I go 1,000, parentheses, 1.05 to the 4th power, I get that amount. I want to put it in money, which means I'm going to round it off to 2 decimal places. So if I do that, I'm going to get approximately $1,215.51. And that would be my answer for that. Then if we go to the next one, the cost of a brand new graphing calculator was $150 in 2016, so here's your A. The value of the calculator decreases at a rate of 8% each year, which means 1 minus 8%, which means 0.92 is our B. Can be modeled by the function, and they give you the function right here. Find the year when the calculator will be worth $50. So they want to know when it's going to be worth $50. Is that our X value or is that our Y value? It's our Y value. So if I write my function, here's my original one. I'm just going to write it out. They're telling us that our Y value, which is f of x, is $50. Now, how are we going to be able to find out the year? Because it's asking us the year, which is the X value. So we're going to use our graphing calculator. So if we take our graphing calculator, go to y equals, we're going to clear our equations that we had from before. And we're going to plug in these 2 equations. So 150, parentheses, 0.92 to the x power. And then our second one is going to be 50 and then we're going to graph. And then the goal is to find out where they intersect. So if I hit this right there, and believe it or not, it is graphing, but I can't see it. So I'm going to go to zoom, and I'm going to say to zoom fit. So I scroll down to where it says zoom fit, and I'm going to hit enter. And now it's going to graph it. Now, when you're graphing these, so I went to window right now, you have to remember the lowest x value that it can be is 0 because we're never going negative. Okay, you can't have a negative year. So I'm going to hit, we're starting at 0. And I'm going to go to my x max. Remember, what is our y-intercept? I'm sorry, I didn't mean to do that for our x. We're going to leave that at -10. I meant to do that for our y. So our y minimum is 0 because you can't go below the y-axis. You can't have a negative year. And our y max looks okay. X, we're going to go from -10 to 10. So now let's see if this is going to let us see it. There's one. There's the other. But we're not seeing quite where they're meeting. So we need to look farther over here. So I'm going to do window. And I'm going to change my x max to be like 30. Just to see if that lets me see where they intersect. So there's the exponential. There we go. So now we see where they intersect. So I want to find that point where they intersect. So we're going to go second, trace, intersect, which was 5, enter, enter, enter. And it tells us they intersect at x equals 13 point something, y equals 50. So x is approximately 13.18 years later. But the question is asking us to find the year. So if it's starting off in 2016 plus 13 years, when do they actually intersect? Or when is it going to be worth $50? In the year 2029. And that would be our final answer. So for this one, because they didn't give us the x value, they told us the y value. We had to actually graph it on a graphing calculator and find out where they intersect. Okay? So your homework tonight is a worksheet. Make sure you show all the same work that I just showed on here. And hope you guys are having a good time.